Do you feel the vibes?
Hey guys, I hope you had a wonderful break and you're all rested. And now we're back, and I know the break was way too short, but it's okay. We're now back. And we're starting chapter 6. Yay! So you should have the lesson plans with you, and I'm sorry I'm not there today, but we are going to do 6.1 with a screencast. And if you can, you already probably noticed that we're doing it a little bit out of order. We're going to do section 1, 3, then 2. It's all good, right? It's all choice. So, okay, let's start with section 1. Okay, so we are going to talk about operations on functions today, right? So we've been dealing with function notation, f of x, g of x, and so on. So suppose you have two functions. You have f of x is some function, and you have g of x is another function, right? If I wanted to add those two functions, f of x plus g of x, in concise form, instead of saying f of x plus g of x like this, I can just write it as f plus g of x. And again, that's just concise short notation for the same thing. And if I wanted to subtract them, it would be f minus g of x. If I wanted to multiply them, it would be f times g of x. There really should be an x there. And if I wanted to divide them, I would say f over g of x. And I have to make sure that g of x isn't ever 0. Okay. Well, let's practice that. I have f of x, and I have g of x, a completely different function. It says to find each and indicate any restrictions on the domain. This is going to come, the restrictions are going to come when you have a variable in the denominator. Right. So here, f minus g of x. F of x is this, minus g of x. So we get 3x squared plus 7x plus 2x squared plus x plus 1. Combine 5x squared. Oops, I'm sorry, this is supposed to be a minus. So minus, and then, so this will be, oh no, that was right. X squared plus 8x plus 1. Okay, and that's it. And because I don't have any variables in any denominator, I don't need to deal with restrictions. Okay, f over g of x, here we're going to divide. So it's going to be 3x squared plus 7x over 2x squared minus x minus 1. Okay, in this case, basically we leave it. Unless there is something that you, a term, a binomial, a monomial, whatever, that you can cancel, then you cancel it. Otherwise, you just leave it the way it is. How about factoring? Do you need to factor out the x in the top? If by factoring, that is going to lead you to a step where you can cancel from top and bottom, yes, factor and reduce. If you can't reduce, then there is no need to factor. It's unnecessary. I would not factor. Leave it like this because you don't want to make a mistake and lose any points. Okay, now we have a denominator with a variable in it. So now we have to come up with the restrictions. The restrictions are all of the points where the denominator equals 0. How do we find those points? I take the denominator and set it equal to 0. Now it becomes a quadratic equation like in chapter 4. Factor okay, so from here, x equals negative a half, x equals 1. So I say here, the restrictions are, semicolon, x can't be negative a half, right? X can't be 1. So these are your restrictions. That's how we do it. Okay, let's move on. Composition of functions. So just like we can add and subtract functions, we can also nest functions. You can actually put one function inside of another. The notation for that is f of g of x, also written as f of g of x. This means take g, put it inside of f. So for example, suppose you had f of x is equal to 3x squared minus 5x. What would f of a be? Well, you would just take a and put them in the place of all of these x's, right? Well, what if I had f of g of x? Well, now you take whatever that g of x function was and you put those in the place of all those x's. Okay, why don't we do an example? Let's find f of g of x and g of f of x, and then find the domain and range. Okay, so first, I want to find f of g of x. I like to write it like this so I can see what's happening. If I want to write f of g of x, immediately when you write it like this, you see you have an outer function and an inner function. What I personally like to do is I seek out the outer function. That's f of x. F of x. And I like to copy down f of x as is right above. So now, what's happening when I go from f of x to f of g of x? This x is being replaced by g of x. So when I go here in my function, wherever I see an x, I'm going to replace just that with g of x. So let's continue. Let's read the function. Negative, so far so good. 3, so far so good. Oops, there's an x there. The x is going to be replaced by g of x, which is negative x plus 8. So now, f of g of x is 3x minus 24. Okay. 3x minus 24, this is a linear function. The domain is all real numbers. The range is all real numbers. And I'm good to go. Okay. Next, we want to find g of f of x. This is the outer function. So I write g of x like this. Okay. So all of my x's are going to be replaced by f of x. Where's the x here? Right there. Write down the negative. X becomes f of x plus 8. So g of f of x is 3x plus 8. The domain is all real numbers. The range is all real numbers. Okay, let's do another one. Okay. So here, f of g of x. Okay, let's write the outer function. So now x is going to be replaced by g of x. X is going to be replaced by g of x. X minus 6 squared plus 2. Okay, so I replace it. I did the replacement. Now I just have to simplify. And you can see why we've been doing all of these types of functions before, right? To get you guys used to this. So here, when I multiply this out, it's x squared minus 12x plus 36 plus 2. So this is x squared minus 12x plus 38. Okay, this is a parabola. Domain is all reals. But is the range all reals? It's not. How do I find what the range is? Well, I have to find the vertex. Remember? Right? Because if it's a parabola, I need to figure out, what the parabola looks like. And so I need to find the vertex. Let's do that. How do we find the vertex? The x-coordinate is negative b over 2a. So that's positive 12 over 2 times 1, 6. The y-coordinate is when you plug in the 6 squared minus 12 times 6 plus 38, 36 minus 72 plus 38, that's 2. So the vertex is 6, 2. This is a parabola that's facing up, so the range is y is greater than or equal to 2. Okay. Let's find g of f of x. Let's write down g of x. G of f of x, right? X is going to be replaced by f of x squared plus 2 minus 6, x squared minus 4. Okay, now this is also a parabola. The domain is all real numbers, but do I have to do all of those theatrics, x equals negative b over 2a, to find where the vertex is? No, I know x squared minus 4 is just a simple old parabola shifted down 4 units, so the range is y is greater than or equal to negative 4. Okay, let's do another one. Okay, f of g of x. So, f of g of x, right? Let's write down f of x. By the way, usually, a student here and there will be like, Mrs. Malika, do I really need to write the f of x on top? You really don't need to. If you can do it without, that's totally fine. I use this in the beginning as kind of like a guide. Okay, so f of x is x plus 4. F of g of x, x gets replaced by g of x. Okay, this is it. The domain is all real numbers. And this is a cubic function, right? So the range is also all real numbers. This one, you can use your calculator to graph if it's like in the cubic ranges. Okay, so now let's find g of f of x. G of x is gonna be x cubed minus x squared. So this is gonna be, okay, x. We replace with f of x. X plus 4 cubed minus x plus 4 squared. Okay? And then you would have to, multiply this out. So this would be, x plus 4, x plus 4, x plus 4, minus, and then the x plus 4 squared, you know how to do, right? Okay. The domain, all real numbers. The range, all real numbers. Okay. Next, how do we do this one? Now I have g of x, f of x here, g of x, and a third function, h of x. Let's take a look at this first one. It wants g of h of 2. G of h of 2. Okay, if that's all you want, there's actually a very easy way to do this. What we do is we start with the inside function. The innermost one is h of 2. Now I know exactly how to find h of 2, right? H of 2, this is h of x. 2 squared minus 1, 4 minus 1, 3. So this is 3. Now I go to my outer one. g of 3. And now I can find g of 3. It's like a puzzle, right? You do that one and then it's like so cool. So g of 3 is 3 times 3 minus 1, 8. Okay, h of negative 3. Let's find h of negative 3. Negative 3 in parentheses squared minus 1 is 8. And so here I want f of 8. 2 times 8, 16. Isn't that cool? Cute little puzzles. Okay. F of a plus 1. That's what we start with. F of a plus 1 is, let's see, what was f of a? F of x is 2x. F of a plus 1, 2 times a plus 1. 2a plus 2. So, h of 2a plus 2. H of x is x squared minus 1. So this is 2a plus 2 squared minus 1. Okay, you see why we've been doing this since chapter 1, right? Because now it's just a smaller part of a big problem. Okay, square this, 4a squared plus 2a times 2, 4a times 2, 8a plus 4 minus 1, 4a squared plus 8a plus 3. Okay, done. Okay, this one. Let's start with the f of g of h of 0. Okay, so we start with h of 0. H of 0, 0 minus 1. Okay, now let's go to the outer one. G of minus 1. 3 times negative 1 minus 1, negative 4. And let's go to the outermost one. F of negative 4 is what? 2 times negative 4, negative 8, and you're done. Very, very easy. Okay. So this one. H of f of negative 2. Okay. Yes, it repeats, but that's okay. So let's start with f. F of negative 2 is 2 times negative 2, negative 4. And then the outer one is f of 4. Oh, no. Sorry, this was negative 4. Oh, got carried away there. F of negative 4 is negative 8. And then the outermost one, h of negative 8, negative 8 squared minus 1, 63. Okay, here. G of f of h of c. Don't worry about the parentheses. It means the same. So let's start from the beginning. From the inside. H of c, c squared minus 1. Okay, here we go. Let me color code this one. F of c squared minus 1, 2 times c squared minus 1. G of all that? What's that? 3 times 6c squared minus 6. No. Sorry, what's G? It's 3x minus 1. So 6c squared minus 6 minus 1, 6c squared minus 7. Okay? And there you have it. That's 6.1. All right, I will see you guys next class. You can go ahead and finish your homework by then and have a wonderful rest of your day.
Press start.